This topic is about the equation of a straight line and being able to identify the y-intercept and gradient of a line from its equation. You need to be able to write down an equation of lines which are parallel and perpendicular to a given line going through a specific point. Feel free to pause as I go through concepts and examples. First thing I'll do is go through all the formulae that you need for this topic. So straight lines are of the form y equals mx plus c, where m is the gradient of a line, straight line, which measures the steepness of a line, and c is equal to the y-intercept. So this is the first formula that you need to know. Graphically, that means if you have a straight line, then the y-intercept is 0c, and the gradient of the line, which measures the steepness of the graph, is if you go across by 1 in the x-axis, then you're going up by m in the y-axis. So that's how it looks graphically. Okay, now gradient, which is equal to m, is change in y over change in x, which is equal to delta y over delta x. So if you have 2 points on this line, which are x1, y1, and x2, y2, then change in y is going to be y2 take away y1. So the distance between there and there, which is y2 take away y1, over the distance between the x coordinates, which is x2 take away x1. So this is the second formula that you need to memorize. Okay, now we've got one equation of a line, which is y equals mx plus c. If you want the other one, imagine you have a straight line and you have a point on that line, which is x1, y1, and then you pick any point on that line. Let's call this point xy. Then according to the gradient formula, m will be equal to change in y over change in x, which is, in this case, is going to be y minus y1 over x minus x1, because we've labeled this variable point as x and y, xy. Okay, so we end up getting m is equal to y minus y1, let's put in brackets so it's easier to see, x minus x1. If I rearrange it, I get m times x minus x1 is equal to y minus y1, in brackets if you want. If I change the sides, so I end up getting y minus y1 is equal to m times x minus x1. Now this is the second equation of a line that you need to know. Now this is more helpful in exams. So as long as you know a point and the gradient of the line, so a point on the line and a gradient of the line, then you can always use this for equation of a straight line. So this is equation of a straight line. Same as this one, equation of a straight line. Okay, so we've got 3 formula here. And the last one that we need to know is, last 2 really. If we have 2 points, x1, y1, and x2, y2. Okay, if we want to find the midpoint, let's call this point the midpoint. The midpoint is equal to, you add the x coordinates together and half it, and you add the y coordinates together and then half it. So that's the midpoint of a straight line. So midpoint of 2 points, sorry. And if I want to work out the distance between 2 points, distance, as a result of Pythagoras, so if I want to work if I draw a right angle triangle, then I know a squared plus b squared is equal to c squared. So I have the difference between the x coordinates squared plus the difference between the y coordinates squared. You add it together and then square root it, you get the distance between 2 points. So these are all 5 formulas that you need in order to tackle questions on equation of a straight line. Okay, and I did say this one is the y minus y1 is equal to m times x minus x1 is the most useful one to remember in an exam. Okay, so the next part is about parallel and perpendicular lines. So parallel lines are lines that never meet. Parallel lines that never meet. And also because they never meet, they have the same gradient. So this is the gradient of L. If this is M parallel, the gradient of the parallel line, that you know if this goes across by 1 and up by M, then this also goes across by 1 and up by M. So if ML, gradient of the line is M, then it implies the gradient of the parallel line is also M. It's the same gradient. Okay, in a similar way, if you have perpendicular lines, so if I draw 2 perpendicular lines, so let's make it go through the origin just to make it easier. Then if I know, let's pick a point on this line, then if I know that it goes across by A and up by B, then the gradient of the line is change in Y over change in A, which is equal to B over A. Okay, now if I rotate this 90 degrees and then end up going like that, then because I've rotated it by 9 degrees, this point has gone here. Now this part is, because I've rotated it by 90 degrees, this is now A, and this part is now B. Now the gradient of the perpendicular is equal to change in Y over change in X. Now change in Y is negative A, because it's gone down by A, over change in X, which is B. Now see that the perpendicular is a negative reciprocal of the gradient of the original line. So gradient of perpendicular line is negative reciprocal of the line. In other words, if ML is equal to M, it implies the M of the perpendicular of the line L is equal to the negative reciprocal, so negative 1 over M. So you need to remember that. So gradient of parallel lines is the same. Gradient of perpendicular lines is the negative reciprocal of the original line. Okay, let's go through an example now to put these concepts into practice. A line is parallel to 5y minus 3x plus 6 is equal to 0 and passes through the point 2 minus 1. Write down the equation of the line. Write your answer in the form ax plus by plus c, where a, b, c are integers, which just means whole numbers. Okay, so the first thing I need to do is I've got this equation of the line, which is 5y minus 3x plus 6 equals 0. I need to write this in the form y equals mx plus c. So if I leave 5y on the left-hand side, then negative 3x becomes positive 3x on the other side, and the positive 6 becomes negative 6. Okay, I still need to write it in the form y equals mx plus c, so I need to divide by 5. So I get 3 over 5x minus 6 over 5. So that means my gradient is equal to 3 over 5 because my coefficient of x is 3 over 5, which implies the gradient of my parallel line is equal to 3 over 5. Now I have a point that this parallel line goes through. Let's just call this x1, y1 is equal to 2 minus 1. Now using my equation of a line formula, which is the more useful one, y minus y1 is equal to m times x minus x1, I end up getting y minus minus 1 is equal to 3 over 5 times x minus 2. Okay, let's simplify this now. I get y plus 1 is equal to 3 over 5 times x minus 2. If I multiply by 5 throughout, I get 5 times y plus 1 is equal to 3 times x minus 2. So I end up getting 5y plus 5 when I expand the bracket is equal to 3x minus 6. I prefer my x to be always positive, so I'm going to move everything to the right hand side. So I end up getting 3x minus 5y minus 6 minus 5, which gives me minus 11 is equal to 0. Now all the coefficients of x, y and the constant are also integers. So a is equal to 3 in this case, b is equal to minus 5, and c is equal to minus 11. Now any scalar multiple of this is also a solution. So this is not a unique solution, there's more than one solution. So anything that is a scalar multiple of this is also a solution. Okay, now let's look at another example. The line L has the equation y is equal to 5 minus 2x. Find the equation of the line perpendicular to L, which passes through the point 3 minus 1. Write it in the form ax plus by plus c, where a, b, c are integers again. So y is equal to 5 minus 2x, which implies y is equal to minus 2x plus 5. So my gradient is equal to negative 2, which implies my gradient of my perpendicular will be the negative reciprocal of this, so negative 1 over negative 2, which is equal to a half. I also know that a point on this perpendicular line is 3 minus 1. So using again y minus y1 is equal to m times x minus x1, I end up getting y minus minus 1 is equal to a half times x minus 3, which is y plus 1 is equal to half times x minus 3. I don't like that half, so I'm going to multiply through by 2. So I get 2 times y plus 1 is equal to x minus 3. Expand the bracket, I get 2y plus 2 is equal to x minus 3. If I like my x again positive, so if I take everything to the right hand side, I get x minus 2y minus 5 is equal to 0, where my a is equal to 1, my b is equal to negative 2, and my c is equal to negative 5. Now let's move on to the next example. So it says the vertices of a quadrilateral ABCD has coordinates so and so. Show that the quadrilateral is a rectangle. Okay, so we've got 4 vertices. So if I draw the rectangle out, okay, now I need to make sure I label the rectangle right, because it's written A, B, C, D here. I need to make sure if I were to draw it, it's A, B, and then C, and then D. So in that order. Okay, now in order to show this is a rectangle, I need to show that this length is the same as that length, and this length is the same as that length. I also need to show that these two are parallel and these two are parallel, but then they all meet at right angles as well. That's quite a lot of things I need to prove. So first, let's start off with the gradient of AB. The gradient of AB is change in y over change in x. So it's going to be 1 take away 5 over 7 take away -1, which is -4 over 8, which is equal to -1/2. Okay, so gradient of AB is equal to -1/2. Okay, if I do the same thing for gradient of DC, again, it's changing y over changing x. So it's 1 take away -3 over -3 take away 5, which is 4 over -8, which is equal to a -1/2. Okay, so I've proven that these two both prove that AB is parallel to DC. Okay, so next thing is I need to work out the gradient of AD. Let me just write that. Gradient of DC is equal to -1/2. Gradient of AD is equal to 1 take away 5 over -3 take away -1, which is 4 divided by the -4 divided by -2, which is equal to 2. So we've just worked out gradient of AD is equal to 2, which implies that AD is perpendicular to AB and DC. Okay, same thing, I need to work out gradient of BC now. So -3 take away 1 over 5 take away 7. I get -4 over -2, which is equal to 2, which implies, again, if I work out gradient of BC is equal to 2. So BC is perpendicular to AB and DC. Okay, again, both of these are saying that AD is parallel to BC. Okay, the next thing, so I've worked out that obviously A to B is parallel to D to C, and also they meet B to C and A to D at right angles. All I need to do to check is the lengths now. So if I work out the length of AB using Pythagoras, so it's going to be -1 take away 7 squared plus 5 take away 1 squared, which gives me 8 squared plus 4 squared, which is square root of 80. If I do the same thing to work out the magnitude of D to C, so the length of D to C, okay, it's 5 take away -3 squared plus -3 take away 1 squared. Again, that gives me square root of 8 squared plus 4 squared, which is square root of 80. Both of these imply that length of AB is equal to length of DC. Now if I do the same thing with the length of A to D, so using the distance formula, -3 take away 1 squared plus 1 take away 5 squared, I end up getting 2 squared plus 4 squared, which is square root of 20. I work out the magnitude of B to C, so the length of B to C, they end up getting 7 take away 5 squared plus 1 take away minus 3 squared, which is 2 squared plus 4 squared, which is square root 20. Both of these imply length of AD is equal to length of BC. Now we have to write our conclusions. So since opposite sides are of equal length and all edges meet at right angles, ABCD is a rectangle. So please ensure that you do write a conclusion in order to get the last explanation mark. Okay, next question. Find the equation of a perpendicular bisector of a line segment joining A, which is 3, 6, and B minus 1, 4. So if I do a rough sketch, so we've got A, which is 3, 6, a rough sketch, so it doesn't matter if it is to scale, minus 1, 4. If it's a perpendicular bisector, first of all, it's a line that goes to the middle of A to B and meets at right angle. Okay, so we need to find the equation of this line. Okay, so the first thing we need to do is find the midpoint of AB, because that will give us this point that this perpendicular bisector does go through. So the midpoint formula is obviously add the x coordinates together and half it. So 3 add -1 divide by 2 and add the y coordinates and then divide by 2, which gives us 1, 5. Okay, so it goes through the point 1, 5. The next thing we need to do is find the gradient of A to B. So gradient of A to B is change in y over change in x, which is 4 take away 6 over minus 1 take away 3, which is -2 over -4, which is equal to a half. Now, because the perpendicular bisector is perpendicular, then we know M perpendicular is a negative reciprocal of a half, so -1 over a half, which is equal to -2. Now, using y minus y1 is equal to m times x minus x1, so the more useful formula for equation of a straight line, then I have y minus 5 is equal to -2 times x minus 1. Okay, if I expand this, I get y minus 5 is equal to -2x plus 2. If I take everything to one side, the left-hand side, I get 2x plus y minus 7 equals 0. And that will be my solution. Okay, let's do an exam question. So the line L1 has equation y equals -2x plus 3. The line L2 is perpendicular to L1 and passes through 5, 6. Find an equation for L2 in the form ax plus by plus c equals 0, where a, b, c are integers. Okay, so we have line 1, and the gradient of L1 is -2. You can clearly see that from that equation because it's in the form y equals mx plus c. Now, gradient of L2 is, because it's perpendicular, it's negative reciprocal of the gradient of L1, which is -1 over -2, which is equal to a half. We also know a point that it goes through is 5, 6. Okay, so using y minus y1 is equal to m times x minus x1, we get y minus 6 is equal to half times x minus 5, which means y minus 6. Let's just multiply 3 by 2, so I end up getting 2 times y minus 6 is equal to x minus 5. 2y minus 12 is equal to x minus 5. If I take everything to the right hand side, I get x minus 2y minus 5 plus 12 gives me plus 7 equals 0. So in this case, my a is equal to 1, my b is equal to negative 2, and my c is equal to 7. Okay, the line L2 crosses the x-axis at point A and the y-axis at point B. So L2 was of the form x minus 2y plus 7 is equal to 0. Okay, so if I rearrange it and get in the form y equals mx plus c, then I get 2y is equal to x plus 7. So y is equal to half x plus 7 over 2. So if its x-intercept implies y equals 0, so 0 is equal to half x plus 7 over 2, which means 0, if I times by through by 2, 0 is equal to x plus 7, which implies x is equal to negative 7. So that means a must be equal to negative 7, 0. Okay, so that's my first point. If I want to find b, I need to find the y-intercept, which implies x equals 0. So I end up getting y is equal to half times 0 plus 7 over 2, which means y is equal to 7 over 2. Y is equal to 7 over 2, which means b is equal to 0, 7 over 2. Okay, now if I were to do a rough sketch of this, it means my a here is minus 7, 0, and my b, which is here, is 0, 7 over 2. Okay, it says given O is the origin, which is here, it says find the area of the triangle OAB, which is this. Okay, so if I go for C here, then area of triangle OAB is equal to half times base times height, which is half times base, which is negative, obviously it goes up to negative 7, so it's 7, times the height, which is 7 over 2. Now you can do this because it's a right angle, obviously triangle, which gives you 49 over 4. And because we don't know the units, and it's the area that we're working out, it's units squared. So that will be answer. Okay, a tree was planted in the ground. Its height, h meters, was measured 2 years after planting. Exactly 3 years after planting, the height of the tree was 2.35. So that means when t equals 3, h is equal to 2.35. And we have when exactly 6 years after planting, t is equal to 6, h is equal to 3.28. Okay, using a linear model, find an equation linking h with t. Okay, so a, because it's linking h with t, and t is the dependent, time is dependent, and h is independent, h must be equal to gradient times t plus the y-intercept. Okay, so if I substitute t equals 3 and h equals 2.35 into this equation, then I get 2.35 is equal to 3m plus c. Okay, and similarly, if I substitute t equals 6 and h equals 3.28, then I get 3.28 is equal to 6m plus c. So I've got a simultaneous equation. So if I do 2 take away 1, I end up getting 3m must be equal to 0.93. 3.28, take away 2.35, which means m is equal to 0.31. Now that I know what m is, I need to find out what c is. So I have, so far I've got h is equal to 0.31t plus c. Now I need to substitute either of these into this. Either points into a substitute. I will do t equals 3 and h is equal to 2.35 into this equation. Then I end up getting 2.35 is equal to 3 times 0.31 plus c. 2.35 is equal to 0.93 plus c, which means c is equal to 1.42. So my equation is h is equal to 0.31t plus 1.42. Part B. The height of the tree is approximately 140 centimeters when it was planted. Explain whether or not this fact supports the use of the linear model in Part A. So because it's when it's planted, I need to work out what h is equal to when t is equal to 0. So when t is equal to 0, h is equal to 0.31 times 0 plus 1.42, which gives you 1.42 meters, which is equal to 142 centimeters. 142 centimeters is roughly 140 centimeters. Therefore, I would say the linear model, linear model is supported.